Now we are interested to see how the climate will react to the changes in greenhouse gas concentration following the three different scenarios or the representative concentration pathways, RCP. As an example, we choose Max Planck Institute Earth System model and look at the output of the model. We select two different variables, near surface temperature and the precipitation. For that, we can use a very nice example of model visualization. Go to this address here, you can see that. It's a tool conducted by German Climate Computing Center, DKRZ, and the Webvis, which is a startup here in Germany doing scientific mapping. And from this tool you can choose, for example, mean temperature change over time. From if you want to have all the three RCPs that they present here, you can choose all the three RCPs. On the left panel you have the RCP 2.6, RCP 4.5, RCP 8.5. And if you want to have more information about it, you just click on the info button. Then you have the information about the RCPs, different RCPs. For example, RCP 2.6 is the 2-degree target, RCP 4.5, delayed climate protection, and the last one, which is business as usual. Now we can go and start our visualization from year 96. Here on the left side you can see, and the temperature anomaly to the period reference period of 1986 to 2005. So the difference between this year and each year, so it shows how much this year was warmer or colder than the reference climate time slice. So I start the visualization. You see, from 2002-3, the the Arctic region is starting to warm up in all of the three scenarios. And if we zoom in our region here, Central Asia, you see in 2030s the climate is getting ready up to between 1 and 2 degrees Celsius warmer than the reference climate. And in RCP 8.5, business as usual, it's more pronounced, and even we reach warming of more than 4 degrees in a business as usual scenario. So that's a kind of example of very nice visualization. You can zoom in, zoom back, look at different parts of the globe. That would be the response of the climate system to the selection of pathways that we choose for emitting our greenhouse gases. You can also look at other variables. For example, let's select just one scenario, for example RCP 8.5. I can also open another window, so then we can somehow compare the two variables, for example temperature and the precipitation, side by side. So I also try to have these the country lines. Here you can click on line, first for English, line, country borders. I zoom again in our region. I choose the change in precipitation over time, for example for the summer times, and I go to year, let's say 2000, stop, go back to year 2000, So I will start both of the simulations. More or less they are showing the differences. Oh well, that should be, sorry, RCP 8.5, because the left one is RCP 8.5. So I start it again. You see how they are changing as the climate gets warmer. Also we have in RCP 8.5 in summer we have also less precipitation, so the warmer area and less precipitation in our region probably gonna lead into drought events, which we have also observed in the observation data. So that's these are some kind of tools that we can use for visualization if we are not an expert. Yeah, as you can see, at the end of the century, yeah, we reach like 4 or 5 degrees Celsius warming, but that's for the summer. But if you look at winter, there are some parts of Central Asia which receive more precipitation, but the problem is when it gets warmer. On the other hand, if you have this warming, let's say I go to 95, here 95, well, here you have 90, come back. Yeah, when you have this extreme warming, so this increase in precipitation would also be cancelled out by evaporation, and the system is gonna be drier. Yeah, the problem is with warming climate, this increase in precipitation would also be cancelled out by evaporation. So when you have like 5-degree increase in the near surface temperature, which means the temperature at 2-meter height from the surface, so the surface might be even more warmer than the atmosphere, and that leads to more evaporation, and the soil gonna be more dry, and that will lead also to dry conditions. So it's a kind of positive feedback in the climate system. So if we rely on our knowledge of climate system, and if our knowledge of the climate system would tell us that our future, due to our greenhouse gas scenario, would look like that, so that might be a very serious problem for us, especially in Central Asia, where the population is very tuned to very small variation of the precipitation, or where the water is scarce.